Okay, so today's notes are on using linear models, and our content objective is to write linear equations that model real-world data and make predictions using linear models. And our language objective is to define linear models, scatter plot correlation, including strong, weak, positive, and negative correlation, as well as trend line. So I started by defining a couple of the words that I just mentioned in our language objective. So the first thing I talk about is a scatter plot. So maybe you guys have heard of what a scatter plot is before, but in case you have not, it is a graph that relates two sets of data by plotting the data as ordered pairs. So it has two different variables. So that's why we're plotting them on an XY plane, because it could compare things like height versus wingspan, or heating bill versus how cold it is outside, but it's relating two different things on a grid. So the reason we plot two different variables on a grid is to see if there's some sort of correlation. So the strength of the relationship between data sets. So you probably have heard about things correlating before, like do good grades correlate with how long you study? Do they correlate with how long you sleep? And that's people asking, is there a relationship between the data sets? Does one predict, or does one seem to go along with another? Not necessarily predict, but seem to go along with or be somehow connected to or related to the other data set. So there are four types that we're going to talk about today. The first is going to be strong negative correlation. So strong negative correlation is if our data set has points that seem to follow a pretty tight trend in the negative direction. So if we had a line drawn through there, our coordinate points would seem to all be going in a negative slope, generally together or pretty tight together. This is compared to weak negative correlation, which would still have a general trend down, but might not be as tight together. So you can see here, the general trend is downward, but it's not clear that it's as tight as the other one is. So that one's a really close correlation. This one is weak, so strong versus weak. General trend is the same, but it's not as close together or as close to a single line as the negative correlation. So the same thing would be true of the positive correlation. So strong positive would be points that make a general trend upwards that are pretty close together, follow pretty close to a single line. Whereas weak positive would be in the general trend of that direction, but not necessarily as tight together or as close to a single line as the strong positive correlation. So make sure you have all this jotted down in your notes. I'm going to flip the page. So that's our start. I'm going to flip the page to go over our example. So I've started writing out this example because it's a bit lengthy. It's a word problem. So modeling often involves word problems, as you may recall. So what we're going to do with this word problem is make a trend line. And a trend line is a line that approximates the relationship between variables or data sets of a scatter plot. So as we saw in our different correlations, they follow a general trend of a line that could be drawn. And the trend line is that line that we can draw and write an equation for. The reason we might do that is because we can do things like use it to predict one variable based on another if we assume it follows that trend line. So what that means, so let's delve into an example so you can see more clearly what I mean. So the example I'm going through today says that the following data set, so this table right here that I wrote out, shows the median home prices in Florida. And I asked, what is the equation of the trend line that models a relationship between time and prices? Use the equation to predict the median home price in 2020. So here it starts in 1940, it goes up to 2000. These are the median home prices in Florida. So the way we would approach this problem is to first and foremost make a scatter plot. So we're always going to start by making a scatter plot so we can see the general trend that is happening here. So to do that, I know my top price here is 100,000. It starts at 20,000 or 23,000. So I'm going to make a grid that goes by 10,000s or so. So I'm going to go 20, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 120. So I counted, I'm using my lines on my paper to be 10,000s, and then I'm going to, actually it's not necessarily down, don't need that arrow there. And then I'm going to go the other way. I go from 1940 to 2000, so I need at least 60 years. There's not as clear of a grid here, but I'm going to give myself some room. So this line, this would be 20,000. This would be 40,000. I'm not going to write the in between 10,000s just so it's not as cluttered. 60,000, 80,000, 100,000. And this is going, I need to label this. So this is the median home price in dollars. And then across here, it'll be years since 1940, since that was my starting year. So I'm going to assume this year would be 1940 here. And then I have 50, 60, 70, 80, 90, 2000. This would be 10 years. This is 0 years, 10 years, 20 years, 30 years, 40 years, 50 years, and 60 years. Sorry, that's a 60. So I started in 1940, that's year 0. So 1940 is year 0, and then this is the years since 1940, so I have 10, 20, 30, 40, 50. So 1940 plus 10 gives me 1950, 1940 plus 20 gives me 1960, 1940 plus 30 is 1970. So if you can see, it's my x-axis is my years since 1940. Okay, so I've made my grid. Now I need to actually plot my coordinate point. So in 1940, there was about 23,000, and as you can see, I don't have an exact grid, so I'm approximating, so I'm getting pretty close. I know it's above 20,000, less than 30,000, closer to the 20,000 range, so about there at 1950. I'm at 40,100, so that's just about at the 40,000 line, maybe just above. It's right about there. Then in 1960, I'm at 58,000, so that's going to be a little bit below 1960 or 60,000. So right about there. 30 is a bit lower than that, so it goes down about the same, but slightly lower maybe. So about the same, maybe a little bit lower. 40 years later, in 1980, it goes up to 89,000, so that's a big jump that year, so that gets a lot closer to 90, way up there. So that's my 90,000 line, so at 40 years, it's going to be a bit higher than that. At 50 years, I'm going to go up to 98,000, so that's way up here, a lot closer to 100,000. And then at 60 years, I'm going to be above 100,000. So 100,000 is going to be, or just above 100,000. 105, so right about, or halfway there, right about there. Sorry, it's between 100 and 110,000, about halfway, right about there. So now I have my scatter plot made. As you can see, there's a strong positive correlation. But what I'm going to do to make the trend line here is draw a straight a line as possible. So I have a piece of graph paper I can use as a straight edge real quick. So I'm going to use a straight edge and try to draw as straight a line as possible through these points. 1 second. So I want it to be as close to the middle as possible, so I'm going to go more or less like, oh, sorry, that's not on the line, that. So this is my line here. This is my trend line. So what I'm going to do is try to choose points that are pretty close to it. So here I got 105,000. I'm actually, because I plotted this slightly off, the math I've done before includes this point and this point as some points that are closer to the line. What's kind of nice is you should get approximately the same values regardless of what points you choose if they're pretty close. So you should get about the same regardless. But I'm going to use these 2 points because they're the values that I've actually already done the math out for. So this is in 1990 and in 1950. So I'm going to choose 2 points that are pretty close to the scatter plot. So, sorry, I skipped a step. Step 2 was sketch the trend line. And step 3 was choose 2 points on or close to the trend line. So because I drew my line slightly off, my math is done to include this point and this point, so I'm going to use those from here on out. You could use this point and this point, and you should get similar values. But again, for the sake of example, I'm going to use the two that I circled. So I'm going to flip the page to give myself room for the next part, if you can bear with me. So the next part, I'm going to actually write the equation of the line using those 2 points. So the next step is going to be write the linear equation using 2 points. So I'm going to use the 2 points that I just came up or that I chose before. So point 1 was 1040,100 and point 2 was 50 and 98,500. So to write the equation, I need to determine slope and then substitute into, I'm going to use point slope form. So first thing I need to do is find the slope. So I know my slope is m, and it's going to be the change in y. So 98,500 minus 40,100 over the change in x, so 50 minus 10. And that ends up giving me 58,400 over 40, which simplifies to 1,460. So my m value is 1,460. And then I can use point slope form. I can choose either of these 2 points. In this example, I'm just going to go with the first one. So I'm going to say y minus 40,100 is equal to 1,460 times x minus 10. So again, I chose point 1 here to plug into point slope form. So I plugged in to point slope form and I have my equation of my line. So now I have a linear equation. If you want to rewrite that in slope intercept form, you can do that. But the last thing that the problem asked me to do was determine or predict the price in 2020. So to predict the price or the median home price in 2020, how many years after 1940 is that? We'll do 2020 minus 1940, and we get that it is 80 years. So 80 years find so we figured out the number of years since 1940, and we're going to substitute and solve for y. So I'm going to plug this in to solve for my y value because I know x represents years. So I'm going to plug in 80 years and solve for y. So I get y minus 40,100 is equal to 1,460 times 80 minus 10. This is why I use the point I mentioned before because I've already done out this math, so I can simplify it for you quickly. But I get y equals, and if I multiply or if I simplify that, I get 1460 times 70. And if I add 40,000 to both sides, I get 40,100. So I just added that to the other side, and I keep simplifying. I get y equals 102,200 plus 40,100. Y equals 142,300. So my answer is in 2020, the median home price in Florida will be approximately, because again, this does not give you an exact value, it's a trend line. So it's predicting a trend, it's not precise. 142,300. So that is our answer. Make sure you write down any questions, comments, concerns you have on this so we can go over it together in class.